You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Since its inception, Amazon Web Services, AWS, has been the best place for customers to build and run open source software in the cloud. AWS is proud to support open source projects, foundations, and partners.
Hey everyone, I am here today with Suresh Chandrasekaran. And Suresh is a general manager at Amazon Web Services. And you're general manager for the Amazon Relational Database Service Group. Mm-hmm. And today we're going to talk a little bit about open source databases, generative AI. But first I'd like to understand why you decided to get a degree in philosophy.
It's actually not a degree in philosophy. It's a PhD, so I'm a doctorate. But my degree is in computer science and in databases, as it turns out.
So your PhD, yes, is
in computer science and specifically in databases.
And your philosophy degree is?
I don't have a philosophy degree. It's just PhD, Doctor of Philosophy, but it's a PhD.
Oh, PhD, Doctor of Philosophy. Oh, yeah. Well, I've been thinking of you as a philosopher all this time, but I'm sure you have philosophies about relational databases.
I do.
So why don't we talk about your philosophies about relational databases? What's your current philosophy now? How do you think that's changed in the past 5 or 10 years?
The way I think about databases, and I've been at Amazon, a little north of 7 years. I have a much deeper appreciation for databases than I even did during my PhD days. And it's a little strange saying that, but I'm truly humbled by the number of customers who essentially bet their businesses, bet their organizations on relational databases, and how big databases are. Like it's in some ways at the lower end of the stack. They're a huge part of what drives the world. And so the value that relational databases bring, and it's 50, 60 years since COD and others at IBM first came up with this concept, it's truly what powers the world.
What was your thinking about relational databases when you were a student? And tell me kind of like your reflection on it now. What are some of the observations you have?
When I was a student, relational databases were already about 25, 30 years in. And a lot of the innovation at that time was more, I'd say, towards the analytics side. And that was a little bit of what I did. My PhD is around streaming databases. And what's really been sort of astounding to me, and in a good way, is that 50, 60 years into databases now, it still remains a hotbed of innovation. There's a ton going on. Amazon Aurora, for example, which is a cloud-native database that Amazon offers, really rethought the storage layer and how some of the technology works. And it's transformed how people think about open source databases. A lot of things that previously were only done through closed source, we now have customers saying, hey, open source technologies have really caught up, and we can bet our businesses on open source relational databases. When
you're thinking about databases now, I'm thinking about your work on the MariaDB Foundation. Mm-hmm. But before we do that, maybe you could tell us a little bit about your overall responsibilities as general manager. Like what are the relational databases that Amazon offers now? I mean, it's grown.
Yeah, it has. So one way to think about Amazon, a framing way to think about Amazon's services is that we want to offer customers choice. And so a lot of what we offer, I mentioned it in my keynote in the context of Influx. When customers want a managed service on top of a database, they come to us, we hear customers, and we work back from customers. So in databases itself, I'm responsible for relational, but our portfolio is much larger. We also offer a bunch of purpose-built databases, time series, graph, and so on. Within relational databases, Amazon Relational Databases and Amazon Aurora, those are umbrella brands. We offer Postgres, MySQL, MariaDB, Oracle, SQL Server, and our newest engine is IBM DB2. And Aurora, which is our cloud-native database that I mentioned, has 2 flavors. One is a Postgres flavor. It's Postgres compatible. There's also a MySQL version of it.
Tell us a little bit about what you discussed in the keynote today. And you were showing kind of the, you had some interesting slides up there. Maybe you could just kind of encapsulate them.
Yeah, so look, the key messages from my keynote were we are increasing our investment in open source. And we've always invested in open source based on what customers have asked us. Early on in AWS journey, what customers were asking us was, we like these open source databases, but we find them hard to operate in the cloud. So a big part of our investment was towards manageability, and that's where RDS came to be, and some of these other managed services. More recently, customers are very comfortable running in the cloud. They love RDS, and what they've said is, we want to improve the core engine. Can you help us with this? It started with something very simple, like bug fixes, security patches. But increasingly, they're also asking us for features because their workloads need to run in some ways. And so in the last 2, 3, 4 years, we have significantly increased our investment into the core open source community, where we're working directly with open source in terms of improving databases and also helping the community thrive.
Tell me then about, where relational databases are in your view right now, because we're hearing so much about generative AI, right? And relational databases, you said, have been around since you were a computer science student and before, right?
Yeah.
And so what's your view now, and how does it fit with this story that we're hearing so much about generative AI?
In Amazon, we have a saying, it's always day one, and I still believe it's always day one, even for relational databases. As I mentioned a few minutes ago, I think of relational databases as being at the heart of a company and enterprise's data. And when you think about generative AI, for a company truly to have unique differentiating value proposition, the generative AI has to be based on the data they've already accumulated from their customers, from their business. And so you may have heard of this concept called retrieval augmented generation.
Yeah.
Right? And what it really does is it allows you to take in a generic LLM and customize the results to your business based on the data you have.
Right.
So what we are hearing from customers is that rather than have a net new vector database, they want us to bring generative AI and vector capabilities into existing databases.
So they want to bring it into like a relational database.
Exactly. Because they have already invested in these open source databases. They already have applications.
So not put the database in the generative AI, but the opposite.
A little bit, right? And so the way we're working with the open source community, but also within Amazon is, I mentioned PG Vector in my keynote. PG Vector brings vector capabilities into Postgres. And right now, the MariaDB Foundation is also working on bringing vector capabilities into Maria. And then another big part of this is, it doesn't start and stop at databases. You have to get from databases through to analytics to your tools on the ML side. And so we're working on zero ETL strategies, which allow enterprises to bring all the data together so that they don't live in silos. So as a customer, you don't have to look at new technology. You get it in your existing technology, and we break down the silos for you.
So tell me about the role of PG Vector then. Can you tell us a little bit about what is PG Vector?
Yeah.
How long has it been around? And how does it serve as being relevant?
Yeah. So PG Vector is an extension in Postgres. So think of extensions as plugins. You can bring your own extension and you can significantly alter the capabilities of Postgres. That's one of the strengths of Postgres. So what PG Vector does is it allows you to store vector types in Postgres. And it also does something called similarity search. So one of the things about generative AI is you're not looking for exact results, right? That's not what an LLM does. But you're looking for knowledge that is close. And the concept of similarity search, or approximate nearest neighbor, is what PG Vector does really well. It's been developed by this fantastic developer called Andrew Kane. He's been at it a few years.
Okay.
And we were the first cloud vendor to partner with him and offer it. It's always been open source, but we offered it in Aurora and RDS early last year. And one of the things that we've been partnering with Andrew is customers love this because, like I said, they want generative AI in Postgres. We're getting a lot of feedback on areas for improvement. And that's really been the journey for us, is working with Andrew on new indexing types, improving performance, directly contributing code. It's been a fantastic journey.
You mentioned a few things in PG Vector, such as indexing. Mm-hmm. What does PG Vector have, and what are some of the different features you would like to see in PG Vector itself?
So when we started working with Andrew, and when we first implemented PG Vector in Aurora and RDS, it had an indexing method called IVFFlat, which is just linked lists. And it was fantastic for building indexes quickly. What it wasn't as good at, which our customers were asking for, was query throughput, especially when you're looking for higher rates of recall, and also iterative development, where you're able to insert new rows on the fly. So we worked with Andrew and we implemented something called HNSW, which uses a different data structure. It's a graph-based data structure, which customers love. And a big part of the work has been to make HNSW as performant as IVFFlat on some of the areas of deficit. And so the work going forward is going to be continuing. It's a fast evolving space. So
Right.
there's a lot we don't know.
Right.
And so we're just keeping a close sort of ear to the ground on what customers are asking for. But really, it's about scale, performance, some of the usual things you'd look for in a database, but in the context of vectors.
Now, the graph-based approach is what you see customers liking.
Yeah, you get better query throughput when you're looking for high rates of recall. And you can also more iteratively add to the database, which you'd expect to see in an operation database because you're constantly running transactions and changing the underlying data.
Because it's a graph.
The graph has to do a little bit more with making it simpler to look for nearest neighbors. That's why it works better.
That's why the nearest neighbors thing is a big
Exactly.
part of
Yeah.
generative AI.
Exactly. And
Yeah.
vector search and similarity search.
So it allows you then to build that capability, the throughput issue. Tell me what are some of the throughput issues that customers face?
It's like any other database. You have an online application, you have customers coming to your store, coming
Yeah.
to your website, and you don't want to experience latency. Now, you want relevant answers based on your own
Right.
like RAG. And so a lot of it is making sure that the database doesn't take a hit or any significant hit when you're running a vector-based use
Right.
case. Because all the things that you'd want in your application, you still want.
Right.
All the asset properties, all the performance properties, and you don't want to lose any of that.
Generative AI is a different beast entirely. What does it make it reflective of what you said when you say that there's a lot that we don't know?
We learn a lot from our customers, right? That's been one of our defining qualities. And the rate of innovation that we're seeing in the generative AI space, frankly, like from my experience, it reminds me of the dot-com boom, like the late 90s, like the internet's new, the world possibilities are endless. And so I expect, the next 2, 3, 5 years, folks are going to come up with new use cases, new ways of using this technology, which is frankly amazing, that we can't imagine right now.
Right.
And so our goal is to stay humble, stay nimble, listen to our customers, and keep innovating as they ask us to do more.
Keep innovating. Okay. So what are some of the things that you are finding that should be in PG Vector, for example, or that customers are asking for that you'd like to build in?
As I said, HNSW is a big lift.
Yeah.
And going forward, it is going to be around continuing to improve performance, continuing to improve scale. We've had customers, with hundreds of billions of objects that they want to index.
Hundreds of billions of
Data points that they want to index
Yeah.
with vectors. And some of these sort of stress the limits of Postgres itself. And so a lot of the work will be both PG Vector, but also in core Postgres. And so we'll continue to innovate. But PG Vector and Postgres are just one part of it. We have other databases. People want
Right.
vector capabilities there as well. So we're working with the MariaDB Foundation. And the other part of it really is simplicity. Customers, just like with RDS when we started, they want to focus on their applications. They don't want to worry about the tool chain. They don't want to worry about generative AI as a tool for them to achieve what they want for their business. So integrating with Bedrock, knowledge bases, a lot of the other things that Amazon's doing around generative AI, offering customers an end-to-end solution.
So dimensions in database are defined by the LLM, and the LLMs continue to become more complex and larger in parameters and everything else. So that has an impact on databases, doesn't it?
It does. So the way to think about it is LLMs are really encoding knowledge in a higher dimension space. And if you have more dimensions, you have to store more data. And you can, in a very tactical way, breach the boundaries of a single page. So one of the things that Postgres has to do also is learn how to deal with higher dimensions and have indexing perform at a high level.
That's an interesting point. Then let's turn to MariaDB because you're on the foundation there, and it's a good example of a database that has to transform with the times too.
Yeah.
What are some of the transformations that we're seeing with MariaDB?
With MariaDB, adoption and continuity is the main focus on the board because the corporation has historically driven most of the contributions to MariaDB. We're now the number 3 contributor behind the corporation and the foundation. And a big part of our focus is to ensure that the MariaDB ecosystem is very healthy. So our core focus still remains contribute code, make sure that it's a vibrant ecosystem. The other part of it is things like Gen AI. MariaDB currently does not have vector support. So it's something that many of the foundation players, corporation are coming together to make sure that we can add something like that into MariaDB so it stays relevant in the generative AI space.
Do you think vectors will eventually just become a feature that we'll see in databases?
I think that's already happening.
Yeah.
A lot of our customers, as I mentioned, are looking for vectors to be a core part. They don't want to change the application, rewrite it, but they want to be able to augment the application to use vectors. Think about it this way. If you had to go use a completely new technology to get advantage of generative AI, there's a learning curve, you have to move your data, and now you may have data in two different places. Customers don't want to do that. They want the data where they already have it. They want the silos to break down, and they want generative AI capabilities in the infrastructure that they already understand.
So then maybe you could provide your context about vector databases from AWS. I'm trying to remember now what that is from you all.
So we offer vector capabilities in a number of our databases. Postgres is one example, OpenSearch is another. And a lot of what you'll see from us is what customers are asking. Give vectors in the databases that you have. A second push for us is what we call zero ETL, to make it easy for data to flow from transactional systems into the data lake, into the analytical systems, so that customers get generative AI capabilities wherever they want it.
And one thing that I find interesting concerns the capability for data scientists to work more closely with developers and infrastructure teams, which comes down to, in some respects, what you're saying about vectors, doesn't it?
It does. And it's really also about breaking down these silos. Historically, relational databases were DBA's concerns. There were data scientists that worked more on the analytic or Spark side. And you're going to see a convergence of this, or I think you will. And so a big part of this is making sure that you take away the infrastructure friction so again, customers can do what they do best.
So relational databases, are they still here to stay?
I think so.
How come?
Like I said, in the end, what relational databases do best, going back to the roots of relational, is ACID. Atomicity, consistency, isolation, durability. Those requirements are never going back. If you have a banking application or anything else, you run a store, you don't want to lose transactions. Relational databases have been the foundation, a very successful foundation of our economy, and I expect that to go forward.
But couldn't an LM start to offer those same features?
The way I think of LLMs is, I do think LLMs have an important role. The way we interact with relational databases can change. Increasingly you're seeing text to SQL, where you ask a question and it generates SQL. But the foundational technology underneath the covers, the thing that makes sure that your data is never lost.
Right.
Think of a banking application. You withdraw from an ATM or you deposit. You never want that deposit to be lost.
Yeah, that
Those in the end are still at the core of what relational databases do best.
Right. Suresh, thank you so much for your time.
Thank you as well.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.